Hello, my dear students and listeners at home. This is St. Charles College Onitsha online teaching. The subject is basic technology, and the topic for today is basic electrical and electronic devices. My name is Onwuegbosi J. Onwuegbosi. Specific objectives. At the end of the lesson, you are expected to define electron emission. 2. List the 4 types of electron emission and define them. 3. Differentiate between conductor, insulator, and semiconductor, and list at least 4 examples of each of the materials. 4. Define the following electronic devices and state their uses: diodes, triodes, transistors, integrated circuit IC. Number 5. Draw the following: diodes, triodes, resistors, capacitors, and inductors. Introduction. Electrical and electronic appliances consist of many different components or devices that enable them function effectively. Example, we have resistors, capacitors, inductors, transistors, integrated circuits, IC. Such electronic appliances include radios, television, computers, DVD, VCD, and others. Electron emission. Electron emission is defined as the process by which loosely bonded electrons in an atom are liberated or set free. Before we go into this in details, we have to look at the structure of an atom. Structure of an atom. Every atom of an element is composed of 2 main parts: the nucleus of the atom and the shells, otherwise called orbits, surrounding the nucleus in concentric rings. The rings contain the electrons, which are negatively charged particles of the atom. The nucleus contains the protons and the neutrons. The protons are positively charged particles, while the neutrons are neutral or uncharged particles. As you can see in the diagram, we have different atoms: atom of helium with 1 ring made up of 2 electrons, and the nucleus as the center. The nucleus contains protons and neutrons, 2 protons and 2 neutrons. Then we have atom of hydrogen, which contains 1 ring surrounding the nucleus and with 1 electron. The atom of carbon consists of 6 electrons. 4 electrons are in the middle, the innermost ring, while 2 are in the outer ring. There is a magnetic force acting between the protons and the electrons. This magnetic force is strongest for electrons in the innermost shells close to the nucleus and weakest for electrons in the outermost shell. Those electrons in the outermost shells are referred to as free electrons because they are loosely attached to the atoms. When 2 bodies are rubbed together, both of them can become electrically charged because one loses its free electron to the other. The body that loses electron becomes positively charged, while the one that gains the electron becomes negatively charged. It is the movement of the free electrons that constitute what you call current flow or electricity. Now we go into details of electron emission. We defined earlier that electron emission is the setting free or liberation of free electrons from the outermost shell of an atom. We have 4 types of electron emission. 1 is thermionic emission. The second is photoelectric emission. 3rd, cold cathode emission. And the 4th, secondary emission. The first 3, thermionic emission, photoelectric emission, and cold cathode emission, are grouped. They belong to the group called primary emission. Then the secondary emission is obtained from the 3 primary emissions. We define them. Thermionic emission. This is a type of emission which involves liberating of free electrons by the application of heat. The continued application of heat to a body leads to increase in temperature of the body, which eventually results in the emission or freeing of the electrons from the body. Examples of bodies that are dependent on thermionic emissions are valves. Example, diode valves, triode valves, and others. Photoelectric emission. This is the type of emission in which electrons are freed from a body by the use of light energy. The amount of electrons so freed depends on the intensity of light applied on it. Examples of bodies that depend on photoelectric emission are photocells. Cold cathode emission or field emission. Cold cathode emission is also called field emission. It is a type of electron emission which involves liberating electrons by applying field energy, that is, electric field or magnetic field. Electron microscope is an example of appliance that depends on cold cathode emission. Secondary emission. This is the type of emission that depends on primary emission methods, that is, thermionic emission, photoelectric emission, or cold cathode emission. It is therefore a type of emission that involves freeing or releasing of more electrons from a body by applying already freed electrons which travel at very high speed. Examples of appliances that depend on secondary emission are computers, television screens, fluorescent tubes, and so on. Electronic devices. These are devices which depend on electric current flow, that is, movement of free electrons, in order to function properly. These include diodes, triodes, transistors, integrated circuit, resistors, capacitors, and the inductors, otherwise called coils or choke. Diode valves. Diode is a semiconductor device which consists of two electrodes, cathode and anode, and allow electric current to flow in one direction only. As you can see on the diagram of the diode, you have a tube containing the two electrodes, that is the cathode and the anode. Then you have a heater which heats the electrode in order to release electrons. Uses of diode valve. Diode valve is used, one, as rectifier for changing alternating current to direct current. It is used as stabilizer for stabilizing current. It is also used for emitting light and for signal detection. It is also used for matching. Triode valves. Triodes are electronic devices which consist of three electrodes. The three electrodes are cathode, anode, and control grid. The third electrode, which is control grid, is at the center between the cathode and the anode. The control grid controls the amount of electrons drifting from the emitter, that is the cathode, to the collector, the anode. Triodes are used for amplification of current. As you can see in the diagram, that is the diagram of a triode valve. You have the heater, which is the cathode, the anode, which receives the electrons released from the cathode. Then you have the control grid, which is at the center. It controls and regulates the amount of electrons moving from the cathode to the anode. Transistors. A transistor is an electronic device which consists of three electrodes. The three electrodes are the emitter E, collector C, and the base. It is made by joining two PN junctions together, that is, joining two diodes together. We have two major types of transistors, the NPN transistor and the PNP transistor. Uses of transistor. Transistors are used, one, for amplification of electronic signal. Two, it is used as a electronic switch or digital switch to turn current on or off in a circuit. Integrated circuit or IC. This is an electronic device which has all the other electronic devices combined in it. Such combination includes diode, transistor, resistor, capacitor, and others. IC is designed in order to make electric appliances portable by excluding the individual components and combining them in a single component. Uses of IC. IC is used, 1, for signal amplification, 2, for limiting of current, 3, it is used as a signal detector, 4, it is used for energy control, 5, it is used for storage of energy, and 6, it is used for stabilizing of current. Conductors, insulators, and semiconductors. Conductors are materials which allow electric current to flow through them because they have a large amount of free electrons in them. We have examples of conductors as iron, copper, aluminum, zinc, tin, lead, and other metals. Insulators, otherwise called non-conductors. These are materials that do not allow electric current to flow. Examples of the reason why they do not allow electric current to flow through them is because they have few free electrons in them. Examples of such materials, insulator materials, are plastic, glass, rubber, and others. Semiconductor materials. These are materials that are partly conductors and partly insulators. They have average number of free electrons in them. Examples of semiconductor materials are silicon, germanium, selenium, gallium arsenide, indium antimonide. All these are different classes of conductors, of materials. Then semiconductor materials are of two types. We have the N-type materials, which are mainly made up of electrons. That is, electrons are negative charges. They are negative charge carriers. Then we have P-type materials, which are mainly made up of protons. That is the positive charge carriers. We have on the diagram the N-type. You have the circles at the center representing the electrons, the negative charges. While the P-type semiconductor materials are those with the plus, that is the positive particles. By joining the N-type, that is the negative type, and the positive type, P-type, together, end to end, we have what we call P-N junction, as shown in the diagram below. Resistors. A resistor is a component of electric circuit which opposes the flow of current in a circuit. Resistance is the ability of a resistor to oppose the flow of current in an electric circuit. They can act as voltage droppers or voltage divider or current limiters in a circuit. Resistance is measured in the unit ohms, and the instrument we use for measuring a resistance is known as ohmmeter. Symbols of resistors. We have two types of resistors symbols. The first one is the fixed resistor. You can see it in the diagram. And the variable resistor, otherwise called potentiometer. The difference is that the variable resistors bear arrow in them, whereas the fixed ones do not have arrow. So you should know the difference. Types of resistor. We have the following types of resistor. You have carbon resistor, film resistor, wire wound resistor, and semiconductor resistor. Capacitor. A capacitor is an electronic component used to store electric charge in a circuit or in an electric field. Capacitance is the ability of a capacitor to store electric charge. We use capacitance-meter or multimeter to measure capacitance. And the unit of capacitance is farad or microfarad. That is for smaller quantity. You have the symbols of capacitor in the diagram below. You have fixed capacitor, you have variable capacitor, and the polarized capacitor. Note the difference in the diagrams. Inductor or coil or choke. An inductor is an electronic component which passes any change in the circuit voltage. It stores energy in form of magnetic field when current is flowing through it. Inductors resist or oppose changes of current. Inductance is the ability of an inductor to oppose changes in a circuit. Inductance is measured in the unit called Henry. Smaller units of inductance are milli-Henry, mH, and micro-Henry. Note the symbols between the difference between milli-Henry and micro-Henry. 1 milli-Henry is equal to 1,000th of a Henry, 1,000th Henry, while 1 micro-Henry is 1,000,000th Henry. You have the symbols of inductors below: the fixed inductors, iron core inductors, variable inductors, and ferrite core inductors. My dear students, we have come to the end of the lesson, and we have to answer the following questions for evaluation. 1. Define electron emission. 2. List the 4 types of electron emission and define them. 3. With respect to their free electron contents, differentiate between conductors, insulators, semiconductors. Give 4 examples of each of them. 5. Define the following: diodes, triode, transistor, and integrated circuit. And finally, number 6, draw the following: 1. Diode, 2. Triode, 3. Fixed resistor, 4. Variable capacitor, and 5. Iron core inductor. Complete the table below. 1. You have item under the heading item, measuring instrument and unit of measurement. So you are required to write the measuring instrument for resistance, inductance, and capacitance, then state their units in the table. You are expected to answer the questions and send the answers to my WhatsApp number 0803 749 3839. Thank you, my dear students, and I wish you all the best. Thank you.